Have you ever wondered what the fastest thing in the universe is? No, it's not a rocket, not a bullet, not even a teenager trying to finish chores after hearing pizza's here. It's light. Light moves at an astonishing 299,792 kilometers per second. That's about 186,000 miles per second. It's fast enough to go from New York to Tokyo 35 times in a single second. But that number, 299,792 kilometers per second, is more than just fast. It's the ultimate speed limit of the universe, the fastest anything can go. Ever let that sink in? We call this speed c, just the letter. It's used in physics equations, like Einstein's famous E.mc2. That's c, that's light speed. It connects energy, mass, and motion in one beautiful compact formula. Now let's go from numbers to something more real. Picture this. You walk outside on a sunny day. You feel the warmth on your skin. That warmth, those rays of sunlight, they left the sun 8 minutes ago. So technically, you're being touched by the past. Every time you look at the sun, you're seeing it as it was 8 minutes earlier. If the sun were to disappear right now, we wouldn't know until 8 minutes later. Kinda spooky, right? Let's go even bigger. The nearest star to us besides the sun is Proxima Centauri. It's about 4.2 light years away. That means if you could travel at the speed of light, it would still take over 4 years just to get there. One way, and that's the closest one. Most of the stars you see at night are dozens, hundreds, even thousands of light years away. That means when you look up, you're seeing light that left its home before you were born, before your grandparents were born, in some cases, before humans even existed. Looking at the stars is like flipping through the universe's photo album. But the photos are old. Every twinkle in the night sky is a message from the past, delivered by light traveling through unimaginable distances just to reach your eyes. And here's the catch. Light doesn't stop. It just keeps going, on and on, until something gets in its way. A planet, a gas cloud, or you. Now how does all this work? Light doesn't need a vehicle. It is the vehicle. It's a form of electromagnetic radiation, a wave and a particle at the same time. That's right, it's got some quantum weirdness going on. And because it's massless, it doesn't need fuel. It just goes. But here's where things get truly mind-bending. Einstein discovered that the speed of light isn't just fast, it's fixed, constant. No matter where you are, no matter how fast you're moving, light always travels at the same speed. You can be standing still or flying at thousands of kilometers per hour. Light moves past you at exactly the same speed either way. That might sound simple, but it changes everything. This discovery shattered the way we think about time and space. If light's speed is always the same, then time and space have to bend to keep that true. So if you move faster, time slows down for you. If you move really fast, space contracts in the direction you're moving. Scientists call this time dilation and length contraction. It's not just theory, we've measured it. There are astronauts who've spent months in orbit and technically aged just a tiny bit less than the rest of us down here. Not by much, but it's real. And it's all because of light speed. Even your GPS uses this science. Those satellites circling above Earth, they rely on precise timing. And because they're moving fast and are farther from Earth's gravity, time ticks slightly differently for them than it does for your phone. Without correcting for Einstein's relativity and the speed of light, your GPS would be off by kilometers every single day. So yes, relativity is in your pocket. Now let's answer the question that everyone secretly wants to ask. Can we go faster than light? The short answer, no. The long answer, not with the physics we know today. As you approach the speed of light, your mass increases. The faster you go, the heavier you become. The heavier you get, the more energy it takes to move you faster. At light speed, your mass would be infinite, and you'd need infinite energy to keep going. We don't have infinite energy, so nature slams the door shut. But science fiction doesn't care. Warp drives, hyperspace jumps, wormholes, they're all ways to cheat the speed limit. Theoretically, some of these ideas aren't completely impossible, just currently impossible. We don't fully understand how gravity, quantum mechanics, and space-time all work together yet. So who knows? The universe may still have surprises for us. Until then, light speed is our ruler, our clock, our cosmic messenger. It defines the size of the universe we can see. Because if light hasn't had time to reach us, that part of the universe is invisible to us. It's not just distance that separates us from other worlds, it's time. Think about this. The light from some galaxies has taken over 13 billion years to reach us. That means we're seeing them as they were near the beginning of time itself. Let me say that again. When you look at some galaxies through a telescope, you are literally witnessing the early universe, baby pictures of reality. And that's why light speed matters. It's not just a number. It's not just a fact in a textbook. It's the limit that shapes our understanding of space, of time, of existence. So the next time you flip on a flashlight, glance at your GPS, or stare up at the stars, remember, you are part of a universe where light is not just fast.